We also need to be able to simplify rational expressions when we are dividing instead. Now, these two problems are the exact same. We can either write this as a fraction being divided by another fraction, or we can write it like this, a fraction being divided by another fraction. These are the same exact problem, and the setup for the first step is going to be the same. Whenever we divide fractions, if you remember from middle school, before we do anything, we keep the original fraction. We change this problem to multiplication, and then you have to flip the other fraction. We are multiplying by the reciprocal whenever we divide fractions. So before you do everything, you have to make sure we're multiplying by the reciprocal. So keep, change, flip. Problem looks just like the first problem we did. Now we're multiplying fractions, so it's time to factor every single part of both fractions and see which factors are going to cancel to 1. So we notice up here, this problem is missing the linear term. So our factors need to multiply to negative 81, but combine to 0. So negative 9 times 9 is negative 81, and those combine to 0. 9 times 7 gets us to that 63. 9 plus 7 gets us to the 16. This numerator will be a GCF problem. And down here, negative 5 times 3 is negative 15. Negative 5 plus 3 is negative. Cancel factors that match because they divide away to 1. So I see my x minus 9s will cancel. I see my x minus 5s will cancel. I don't believe anything else can. So I look at what's left, and I'm going to organize that as multiplication in my final answer. Then I look at what's left downstairs, and I have 2 factors still. So it'll end up being x plus 7 down in the denominator and x plus 3. And there's our final answer right here.